Operator and associate roles in semiconductor equipment manufacturing. In the world of semiconductor equipment manufacturing, operators and associates play essential roles that directly support innovation and the advancement of modern technology. This presentation offers a comprehensive overview of career opportunities in this high-tech field. From handling sophisticated tools to supporting key production workflows, these professionals ensure that the equipment used to fabricate microchips runs smoothly and efficiently. Semiconductor equipment manufacturing is not just about machines, it's about the people who make those machines operate at peak performance. In this session, we'll explore three critical areas: job roles and responsibilities, the safety and work environment, and finally, the outlook for career growth in this field. These roles are vital links between complex equipment and technological innovation, creating a pathway from tools to skilled operators to breakthrough advancements in microelectronics. What is semiconductor equipment manufacturing? Semiconductor equipment manufacturing is the backbone of modern technology. It involves creating the highly advanced machines that are used to build the microchips found in nearly every digital device today, from smartphones to supercomputers. These machines power processes like lithography, etching, deposition, and testing, each of which is essential to shaping and finishing semiconductor wafers. The complexity of this industry is staggering, with over 300 distinct process steps involved in fabricating just one chip. It's no wonder the industry employs a global workforce of over 500,000 professionals. The market itself is massive, exceeding $100 billion in size, and continues to grow as demand for electronics expands. Because of the delicate nature of microchips, the precision required in this industry is astonishing, often reaching 99.9% accuracy or higher. This sector is not just manufacturing, it's enabling the digital world to function. Core equipment categories in semiconductor manufacturing. Semiconductor equipment manufacturing includes several core categories, each essential to the fabrication of microchips. First is lithography, which involves pattern creation. This process uses light to transfer circuit patterns onto silicon wafers, essentially defining where components will be placed. Next is etching, where unwanted material is removed to carve out the intended design, adding precision to the layout. Then we have deposition, which is all about building up layers of materials, often just atoms thick, that will form the different functional parts of the chip. Inspection comes next, playing a critical role in quality control. This step ensures there are no defects that could compromise chip performance. Finally, we reach testing, which verifies performance by making sure the chip behaves as expected. These 5 categories, lithography, etching, deposition, inspection, and testing, form the technological backbone of semiconductor equipment operations. Role overview. Who are semiconductor operators and associates? Semiconductor operators and associates are essential to daily manufacturing activities. At the entry level, equipment operators are responsible for monitoring and controlling manufacturing tools. With just 3 to 6 months of training, they become adept at managing complex systems. Process associates, who typically have 1 to 2 years of experience, focus on quality control and optimizing production efficiency. Maintenance technicians, requiring more than 2 years of specialized training, handle preventive maintenance and repair of critical equipment. At the leadership tier, senior associates bring 3+ years of experience and drive continuous improvement while leading teams. Core responsibilities across all roles include operating equipment, monitoring processes, inspecting quality, recording data, and ensuring safety compliance. The semiconductor environment runs 24/7, supported by a structured 3-shift schedule. These professionals ensure stable and high-yield operations in one of the most technically demanding manufacturing sectors in the world. Workforce overview. Who are semiconductor operators and associates? The semiconductor industry in the United States employs over 150,000 operators, highlighting the critical scale of this workforce. These individuals form the foundation of semiconductor manufacturing by ensuring that production runs smoothly and efficiently around the clock. Salaries for these roles typically range from $45,000 to $75,000 annually, depending on experience, specialization, and location. The industry also offers promising future prospects, with a projected job growth rate of 15%, reflecting the increasing global demand for semiconductors in everything from consumer electronics to defense systems. In addition to financial stability and career mobility, job satisfaction is remarkably high, standing at 85%. This is often attributed to the combination of hands-on technical work, strong team environments, continuous learning, and meaningful contributions to advanced technologies. Together, these factors make semiconductor operator and associate positions both rewarding and in demand. Daily responsibilities and tasks. In the world of 24/7 semiconductor manufacturing, responsibilities shift with each work period to maintain seamless operations. The day shift, running from 6 a.m. to 2 p.m., marks the peak activity window. This is when equipment is started up, performance is assessed, and any necessary handovers from night maintenance teams occur. It's a critical time for launching the day's production and ensuring a smooth transition into manufacturing. The swing shift, spanning 2 p.m. to 10 p.m., is intensely focused on production. This is when operators and engineers closely monitor processes and perform ongoing quality checks. Their role is to ensure that production remains stable and meets quality standards without interruption. Finally, the night shift, from 10 p.m. to 6 a.m., is dedicated to system upkeep. Maintenance activities, including optimization, recalibration, and deep cleaning, take place during this quieter period to prepare equipment for the next production cycle. Core daily tasks and workflow. In semiconductor manufacturing, core daily tasks are the building blocks of shift success. Equipment startup is a critical priority, typically taking 15 minutes as tools are initialized and safety protocols are confirmed. Once production begins, process monitoring runs continuously for about 8 hours, requiring constant vigilance to maintain parameters. Quality inspection is also essential, occurring every hour, with each round taking about 30 minutes. This ensures any defects or anomalies are caught early. Data recording happens in real time throughout the shift, supporting traceability and decision-making. Maintenance tasks are scheduled and take about 45 minutes to complete, keeping systems optimized. Finally, the shift ends with a 20-minute handover, ensuring smooth transition and alignment between teams. The typical workflow includes a safety check-in, equipment review, production start, and continuous monitoring. Key metrics include a 98.5% uptime target, 15 quality checks per hour, and monitoring of 4 key systems. Work environment, the clean room. In semiconductor manufacturing, clean rooms are ultra-controlled environments designed to minimize contamination. These spaces are classified according to ISO standards based on how many particles are allowed per cubic meter of air. ISO Class 3 cleanrooms are considered ultra-clean, allowing no more than 1,000 particles per cubic meter. These areas are reserved for critical processing steps, such as advanced deposition or etch processes. ISO Class 4 cleanrooms, with a limit of 10,000 particles per cubic meter, are used in advanced lithography, where extreme cleanliness is still essential. ISO Class 5, allowing up to 100,000 particles, represents the standard fab environment, where general manufacturing takes place. Meanwhile, ISO Class 6 cleanrooms allow up to 1 million particles and are typically used in support areas such as assembly and packaging. Each classification reflects the strict cleanliness needed to ensure process stability and product yield. Work environment, the clean room, environmental controls. Clean room environments are tightly regulated to prevent particle contamination and maintain product integrity. Temperature is kept within a narrow range of 20 to 22 degrees Celsius, ensuring thermal stability for sensitive equipment and materials. Humidity is maintained at 40 to 45%, which helps control static electricity and prevent moisture-related damage. airflow plays a crucial role with speeds regulated between 0.3 to 0.5 meters per second. This airflow helps sweep away particulates and keeps contaminants from settling on surfaces. Positive pressure is another key factor. A differential of +5 pascals ensures that air flows outward from the cleanroom, preventing unfiltered air from entering. Most importantly, cleanrooms utilize laminar airflow, a unidirectional flow of HEPA-filtered air. This flow pattern helps maintain cleanliness by continuously flushing out contaminants, making it essential for consistent, high-precision semiconductor manufacturing processes. Work environment, the cleanroom, safety and PPE requirements. Maintaining cleanliness and safety in a cleanroom requires strict adherence to personal protective equipment and behavior protocols. Full gowning is essential. Employees must wear head-to-toe cleanroom garments including gloves, booties, hairnets, and coveralls to reduce particle shedding. Before entering, individuals pass through an air shower, which blasts high-velocity air for 30 seconds to remove any remaining contaminants on garments. Hand washing must be performed following strict protocols using specialized soaps and drying procedures to eliminate microbial and particulate risks. No cosmetics are allowed inside the cleanroom. Items like makeup, perfume, and jewelry can emit particles or volatile substances, leading to contamination. Chemical safety is equally critical. Workers are trained on proper handling, ventilation, and spill response procedures to prevent accidents. Finally, daily training reinforces safety practices, ensuring that personnel stay current with safety briefings and protocol updates, essential for protecting both products and people. Essential skills and training requirements. To succeed in semiconductor manufacturing and related technical roles, a strong foundation in essential skills and training is critical. Key technical skills include equipment operation, which is considered critical and must be performed at an expert level. This means being able to run, monitor, and adjust machinery with precision and confidence. Quality control is marked as essential and should be performed at an advanced level, emphasizing accuracy, compliance, and detection of defects in materials or processes. Data analysis is important and requires an intermediate level of skill to interpret production data, detect trends, and support process improvement. Troubleshooting is another critical skill, demanding advanced capability to quickly diagnose and resolve equipment or process issues. On the education side, a high school diploma is the minimum requirement. A technical certificate, typically completed in 6 to 12 months, is preferred. An associate degree in electronics or engineering provides a competitive advantage. Training timeline and soft skills. The journey to technical proficiency begins with a structured training timeline. In the first 1 to 2 weeks, the focus is on safety and orientation. This includes cleanroom protocols, understanding contamination controls, and basic safety procedures essential for working in semiconductor environments. From months 1 through 3, employees enter the equipment training phase, learning hands-on operation and basic maintenance of tools. Months 4 to 6 shift into process certification, where deeper skills in quality control and troubleshooting are developed. After this foundation, learning becomes ongoing. Advanced skills training continues indefinitely, focusing on leadership and working with specialized equipment as responsibilities grow. Alongside technical training, soft skills play a key role in success. Precision and attention to detail ensure accuracy. Teamwork fosters collaboration. Problem-solving demands critical thinking, and clear, concise communication is essential for efficient and safe operations across teams. Industry certifications and career outcomes. Certifications play a vital role in building technical credibility and job readiness. Key industry certifications include OSHA 10, which sets a foundational standard for workplace safety and is especially important in cleanroom environments. Semi-standard certification ensures familiarity with global equipment safety practices, vital for handling advanced manufacturing tools. The 6S methodology focuses on workplace organization: sort, set in order, shine, standardize, sustain, and safety, essential for operational efficiency. SPC training, or statistical process control, enhances understanding of process behavior and supports defect reduction. The overall training path typically spans 6 to 12 months. After completing the program, participants enjoy a strong 95% job placement rate, highlighting the demand for skilled workers. The average starting salary is $45,000, reflecting industry value for trained talent. And learning doesn't stop at graduation. Continuous 24/7 learning ensures that individuals stay current with evolving technologies and workplace requirements. Safety and quality standards. Comprehensive safety and quality standards are essential to protect workers and ensure product excellence in semiconductor manufacturing. Under OSHA safety requirements, personal protective equipment, or PPE, is critical. This includes full body coverage and chemical-resistant clothing, as outlined in Regulation 29 CFR 1910-132. Hazard communication is required and involves correct labeling of chemicals and understanding safety data sheets, per 29 CFR 1910.1200. Respiratory protection is deemed essential, as described in 29 CFR 1910.134, and covers air filtration and medical evaluations to ensure employee health in chemical environments. On the quality side, ISO standards provide global benchmarks. ISO 9001.2015 is a core quality management standard, focusing on process control and continuous improvement. ISO 14644 is critical for cleanroom standards, managing contamination and air quality. SEMI standards, categorized as industry level, ensure equipment safety and alignment with automation protocols. Together, these frameworks uphold safety, consistency, and regulatory compliance. Daily safety protocols and quality assurance measures. Maintaining a safe and high-quality manufacturing environment depends on disciplined daily practices. On the safety side, each day begins with mandatory pre-shift safety briefing attendance. These meetings review any recent incidents and reinforce awareness of current risks. Equipment safety inspections follow, ensuring all tools are functioning correctly and within compliance. Emergency procedures are reviewed to keep staff prepared for fire, chemical, or power-related incidents. If any unsafe conditions arise, incident reporting documentation must be completed immediately for accountability and corrective action. On the quality assurance side, statistical process control, or SPC, is used to monitor process behavior and detect variability. Inline inspection and testing are conducted during production to catch defects early. Real-time data monitoring enables proactive response to trends. Continuous improvement cycles aim to eliminate inefficiencies, while document control and traceability ensure every change and result can be tracked and verified for audits and optimization. Safety and quality standards. Our commitment to safety and quality is evident in the strong compliance frameworks we've built to protect both people and products. We maintain 90% safety compliance with OSHA standards, which ensures a secure working environment and adherence to regulatory requirements. Our quality systems are even more robust, with a 99% quality rating under ISO 9001 guidelines, highlighting our excellence in consistent product delivery and continuous process improvement. The incident rate stands at just 0.02%, placing us among the industry's top performers when it comes to minimizing workplace accidents. We achieve this with 24/7 real-time monitoring systems that help identify risks before they escalate, allowing for immediate corrective action. Finally, our staff training rate is at 100%, meaning every employee is fully certified, equipped, and prepared to maintain both safety and quality in every task they perform. Career advancement path. Our structured career advancement path empowers employees at every stage, beginning with Operator I or associate roles. These entry-level positions, requiring 0 to 1 year of experience, focus on basic operations, safety compliance, and accurate data collection with a salary range of $35K to $50K. As individuals gain experience, they can move into Operator 2 roles after 1 to 3 years, where they perform independent operations, oversee quality control, and conduct basic maintenance. This skilled role offers a salary range of 50K to 60K. With 3 to 5 years of experience, employees can progress to the senior operator level, specializing in complex equipment operation, advanced troubleshooting, and mentoring others, earning between 60K and 75K. The final step is lead operator or supervisor, requiring 5 to 8 years of experience, where individuals lead teams, optimize processes, and coordinate training, with salaries from 75K to 95K. Career progression and opportunities. Clear pathways for advancement and professional development are essential in semiconductor manufacturing, and our career progression model supports that growth. Employees can pursue specialization in 3 key areas. First is process engineering, where the focus is on optimization and innovation, ideal for those interested in improving process efficiency and integrating new technologies. Second is equipment maintenance, which requires deep technical expertise for troubleshooting and maintaining critical systems. Third is quality assurance, a path centered on enforcing standards and driving continuous improvement through rigorous control systems. To support these specialization paths, we offer a range of growth opportunities. Employees can earn certifications to validate their skills, participate in impactful projects that build experience, engage in mentoring relationships that transfer knowledge, and pursue further education to enhance both their technical and professional capabilities. These combined pathways help build a future-ready, skilled workforce. Career progression and opportunities. Our organization is committed to clear and rewarding career advancement, supported by strong metrics that reflect real growth and employee satisfaction. An impressive 85% promotion rate within 3 years shows that most team members move up quickly, demonstrating a culture that actively recognizes and rewards performance. Additionally, employees receive an average 20% annual raise, driven by individual achievements and performance-based evaluations. These compensation adjustments reinforce our merit-based philosophy and encourage continuous improvement. The average time between promotions is just 18 months, signaling fast-track opportunities for those who consistently deliver results. Just as important, our 95% retention rate is a strong indicator of employee satisfaction, engagement, and loyalty. Together, these numbers highlight a workplace culture built on advancement, fairness, and fulfillment, making it possible for team members to grow both personally and professionally over the long term. Industry outlook and future trends. The semiconductor industry is experiencing rapid and sustained global market growth, projected to exceed $1.2 trillion by 2030. This growth is supported by strong job market trends. Equipment operators are expected to see job growth of 60%, which is much faster than average. Process technicians are also in high demand, with a projected 52% growth rate, reflecting above-average expansion. Maintenance specialists, though currently in critical shortage, show a 48% job growth rate, indicating strong and urgent demand across facilities. Meanwhile, technological adoption is transforming the industry. From 2024 to 2030, we will see increasing integration of AI, IoT, and full automation, culminating in the emergence of quantum technologies. AI and machine learning are growing at 45%, revolutionizing predictive maintenance. IoT is expanding by 38%, enabling smart manufacturing. Advanced automation is accelerating at 52%, streamlining operations through robotics. These trends promise exciting opportunities and the need for a highly skilled workforce. Industry outlook and future trends. The semiconductor industry is undergoing transformative expansion, driven by significant investment and emerging career opportunities. Global industry investment is projected to reach $527 billion between 2024 and 2030, creating an estimated 2.8 million new jobs. At the forefront of emerging roles are AI-assisted operations, where humans and AI collaborate to enhance efficiency and decision-making. Also in demand are cybersecurity specialists focused on protecting industrial systems, sustainability engineers supporting green manufacturing initiatives, and quantum device technicians pioneering next-generation technology. By 2030, the industry is expected to grow at a 15.3% CAGR, reaching a market size of $1.38 trillion. Automation is scaling rapidly, with 75% process automation already in place. Cutting-edge node sizes have reached 3 nanometers, and operations now run 24/7, reflecting the sector's continuous nature. With 95% job security, the industry offers strong stability and long-term career potential for technical and specialized roles.